I mean,
all right, project 4 in a nutshell. I already explained this whole thing to the class and then forgot to record, so I'm going to explain this in super fast mode, and let's see if I can do this. So for this project, we're trying to find the minimum overlap of sets that still cover all points. For example, say you have multiple groups for a project in our class that need to be presented. Your professor must grade every student. So I have to grade every student within the class, or at least a certain number of them. Your professor, but I don't mind grading a whole project, and when I grade a project, I grade every student, but I don't want to grade more students than I have to. So how can we minimize the number of times we have to grade a student? This, I think, makes the most sense when we go down to an example. If these are the groups, I've reduced all students down to numbers, 0, 2, 5, 0, 2, 3, 1, 2, 3, 6, 1, 4, 3, and 5, 6. If these are the sets, and I want to find the minimum of 2 of having to grade just students 0, 2, and 6. So notice I may not have to grade all of them. I can just grade a subset of them. The question is, if I need to grade students 0, 2, and 6, how many grades must I assess? So to do 0, 2, and 6 on that set file, I have to grade at least 5 students, which represents choosing 0, 2, 5, and 5, 6. So this group right here and that group right there. All right, Brian. Notice that there are multiple answers to this one. I could have done 0, 2, 3, and 5, 6. Obviously, the minimum of 1 is just 1, and the minimum of 1, 2, 2, 3 is 7. Notice in this case that I chose 2 twice. Maybe I misplaced a grade, and I need to grade student 2, so I need to have 2 unique grades for the student, in which case I have to grade these over here. Where quickly all students are given an ID, and let's see, and a student may only be a student can only be, a student can be a member of multiple groups, but he can't be inside more than once in a group. That doesn't make any sense. The interface right here, minimum overlap, I'm going to give you the set file in your constructor. You're allowed to take a good amount of time to process the set file if you wish. Make sure it's only no more than a couple of minutes, otherwise I will not grade the rest of your assignment. But the main one I'm grading for speed is a find minimum overlap, where I pass in the cover, aka which students I want to assess. So in this case it would be a vector of 1, 2, 2, and 3. And I'm passing print, which goes in print is just for debugging. If print is true, then it prints off debug information. Otherwise, if it's false, it doesn't. Algorithm setup. For this assignment, I am expecting you to do a recursive backtracking solution. So you must follow this template. Obviously, this template can exist. You can manipulate this template as you see fit, but it still needs to exist overall. Find minimum overlap so far will represent of the set of students that you've selected so far. Input will represent the numbers, the students that you need to select, and then print is just for debugging. You begin minimum at uint max. The reason for that is that if you can't find a set, then you just return uint max, which is -1. Then what you do is for each set S in the set files, wherever that's stored, the result is input minus S, so you take away all the students that are in the set, aka that group project, subtract from S, and you store it in result. If your result has 0 members left in it, that means the professor has graded each of the student. Then if so far plus S, aka what we've selected so far plus the S, has fewer students than main, then the min is the size of those two. Otherwise, we didn't find a cover, so we'll append S to so far, and then we'll recurse, passing again so far, our result that we've hopefully subtracted up here, and then print. And then we'll get back an answer eventually, because this is recursive backtracking. If the new answer is less than min, we update min, and then we remove S from so far, because we added it here, we need to remove it again, so when we go back to the next set, it'll be us selecting the next set to move on. And then at the end, we return min. As usual, I only need this interface. You can add more functions, you can add more classes, but you must adhere to this interface. Naturally, you're going to have to set up at least one more function for this new find minimum overlap recursive call. Notice I have not defined what so far is. You are free to make that whatever data structure you wish, as well as input, as well as adding possibly other parameters as well. Let's see. Keep in mind that the above is pseudocode. I never told you what so far is, so you can do it. You should Keep in mind that I'm going to be running minimum overlap multiple times on the same set file, so I strongly recommend using global data. And you're allowed to use anything from the STL, so vector, list, queue, stacks, maps, multi-maps, etc. When you run this, I'm going to go down here. For example, this is the binary produces, passes the set file, then yes for debug information, and then each of the queries are going to be in quotes. So the first time I'm asking for students 1, 2, 3, 4, 5, 6, 7. There are the answers. The next time 0, 3, 7, 12, 13. The next query is just for these students, etc., etc. And the main program I've written for you should automatically test these covers and then give you found a minimum of how many elements in a certain amount of time. Naturally, if you run it right now, it's seg faults because the code has not been implemented yet. All right, memory management, of course, keep managing your memory. You gotta manage your memory if you want full credit. It's due December 6th, which is that Friday, last day of class. Now, if you look inside the make file I provided, I've started with small 30, medium 30, large 30, 100, and small 30 as well. These are to get you started. The real timings are going to be down here. I really jumped past those, so medium timings, large 30 timings, and large timings as well. I highly recommend you start with small 30, so you can do make small 30, and it'll automatically compile everything and then run it, your test. Naturally, it's seg faults because you haven't implemented the code. All right, so that was my quick summary of everything I just talked about. If you have any other questions, please email me.